tutorial series in Kerbal Space Program 0.90 Beta. And in this episode, I want to explore the sandbox mode. We spent 2 episodes on career mode, and that's all well and good, but sandbox mode provides certain opportunities for exploration in the game that might take a while to get to in career mode. So, YouTube Sandbox, let's begin. The first thing you'll notice about sandbox mode is that we have much bigger buildings. We have lots and lots of buildings. And basically they provide the same functions, but they're completely unlocked. They don't have any... See, it says fully operational. There's no limit to them. You can build craft with any number of parts, launch spacecraft with any amount of mass, well, we can't have science. And we can't have reputation, and we don't have funds, right? You can see there's no display of those things on this, and that is because they don't matter anymore, because this is sandbox and you can do whatever you like. And in this exploration of sandbox mode, I want to take a look at something that we would otherwise take a while to get to, and that is aircraft. So this is the spaceplane hangar. And functionally it's very similar to the VAB, the Vehicle Assembly Building. However, it is, well, basically it's oriented horizontally instead of vertically. So whereas the Vehicle Assembly Building stacks things vertically, here you're going to orient things horizontally, and that's the big difference. Here we've got the Mark 1 cockpit, the sort of standard cockpit if you will, but it's got a companion, the Mark 1 inline cockpit. So you can use either one. I'm going to start with this cockpit because it's the most straightforward one, I think. And we have some key features here. First is center of mass, and the next is center of lift. Right now there is no lift. We have no airfoils. I don't think this is a lifting body. No, it isn't. There are some of these that are lifting surfaces. So you see here the Mark 2 cockpit is. Mark 2 cockpit has a lifting surface lift rating of 0.6. But this does not. You'll also note the reaction wheel. I talked about that in the previous episodes. The reaction wheel torque, which allows you to maintain stability and turn the vehicle even without reaction control systems. And reaction control systems, that's the thing to mention, are these little thrusters that help you turn your vehicle in space. We haven't done much of that yet, and I'm not going to in this episode because we are going to design an aircraft. So, well, we could go with these. So, there's basically a few platforms. There's the Mark 1 stuff, which is basically the same as these 1.25 meter fuel tanks that we've been using on the rockets as well. So, for instance, there's rocket fuel for you. Or you can go with the Mark 2 objects, the Mark 2 tanks, and for that we would use this cockpit. Right, and so this has a sort of neat profile, provides lift and everything, and you can use the Mark II shaped parts for that. And there are adapters for everything, so you can go from 1.25 meter to Mark II, and then from Mark II to the other possibility, which is Mark III. But I'm not going to go there just yet. It's best to start small. And in this case, we've got the Mark 1 cockpit, and I'm going to try and make a rocket plane. Now, we could do all sorts of stuff, but I think I'm just going to... Yeah, well, maybe I should start with a jet, right? Because it's a little bit more... Actually, jets are somewhat more complicated than rocket planes in terms of calculating things for them. But for a jet, all you need is liquid fuel because you're going to be sucking oxidizer out of the air. So, the way rockets work is they mix liquid fuel with oxidizer, oxygen. You need oxygen to burn stuff. Or some kind of oxygen-like thing like fluorine. But oxidizer is necessary for a rocket because you can't get oxygen in space. But a jet just sucks oxygen out of the atmosphere and uses the atmosphere in order to combust the liquid fuel. And so all we need is liquid fuel. We don't need oxidizer for a jet. On the other hand, we don't need too much liquid fuel. So let us put some tanks of it. I forget if there must be some empty tanks. So the benefit of Sandbox is you can try things out before spending money on them. Ah, here we go, structural fuselage. You can see all the parts that you can eventually unlock, and maybe even make a plan for, you know, maybe down the road you want to make a certain vessel, and so you can decide in your career mode to unlock certain technologies in order to eventually get to the point where you can unlock that technology and unlock that vessel. So you can sort of plan ahead like that. You can sort of freeform design things. Career mode is sort of for people with need for some sort of definite mission, plan, or objective, whereas Sandbox is for, you know, those who like to play with Legos, basically. This is the Lego mode. And so if you just want to have a box of Legos to play around with and to build whatever you like, this is the place to do it. Now, we've got a lot of new features in this mode. For instance, let's see, for a jet we need some intakes, right? So here are radial air intakes. But they jet out quite a lot more than I'd like them to. And actually I want some angle snap as well. So angle snap snaps it to the angles, and they're pretty unsightly, honestly. But we can fix that. Now we have this offset, and I'm going to take this, I'm going to shove it in a little bit. Just... oh, that's about right. That's not too bad, is it? That makes a little bit more sense. And you notice that has the same effect on the symmetric part, so we don't have to do it separately for each one. You want to be careful about using the offset tool and the rotation tool, because it can go horribly wrong. You don't want to, you know, have strange things happening and end up with a vehicle that won't do what you want it to. But anyway, so we're going to suck the oxygen out of the atmosphere, we've got liquid fuel to burn, and we've got a jet. We've got the center of mass around here. We should build our wing close to that point. So let's start there. We don't need too much of a wing for such a small vehicle, such a light vehicle. And before people in the comments get at me for, I did all the mass calculations allowed last time. Of course, you can look here. Here we go. You've got the mass, 3.7 tons, 8 parts, and you got the height, width, and length. I really like the height, width, and length. That's really hard to determine unless you have that listed for you. The mass, of course, you can figure out for yourself, but anyway, it's nicer to have it there. So, a good old-fashioned delta wing sounds like a good idea, and that's about the right place to put it. What you want is for the wing to be, well, the center of lift, to be slightly behind the center of mass, but not too far. The further away it is, the more likely your plane will flip out. If it's in front, your plane will definitely have all sorts of stability problems. But just a little bit behind is good. But I don't like the delta wing. It seems too simple. And this is a pretty straightforward jet. I view this more like a jet in the 50s and 60s. How about it's just a swept wing? No, that's really thin, isn't it? And so you can go on like this. The thing about Sandbox mode is you have so many choices that you're going to end up spending a lot of time in here wondering if you've really got the thing you want. And tweaking things, and now we've got all of these other features in the mode. It's a little bit behind, isn't it? That you could literally do, you know, you could make the wings very interesting indeed with the positional tools now. The gizmos, as they call them. That's a pretty darn big wing. Oh, well, let's give it a little bit of tilt here. So what I'm going to do is I'm going to push Shift W. No, that's the wrong one. Shift E? Yes, Shift E. Okay, Shift E to lift it up like that. Now, if I try and do that with this, I won't be able to attach control surfaces right. So let me get the control surfaces on first, and then I think sometimes I think if I turn off angle snap, it'll work all right. But okay. Now we can do Shift E to lift it up properly. Okay. That's an interesting looking plane. Its center of mass is a little bit back. I don't like like that too much. I wanted center of mass a little bit further forward. There's a few ways of doing that, but my favorite way by far is the canard. Normally you'd want some sort of horizontal stabilizer behind here, but I have a thing for them up front, but that causes my center of lift to go really far forward. Now, not all things that make sense aerodynamically in real life really make sense aerodynamically in Kerbal Space Program. I must caution you that Kerbal Space Program's aerodynamics are a little bit odd, and I think I'm going to go with a different plan for the air intake here. Let's not do sideways, because I have to put the canards close to that area, and that's not working out right now. So let's put it on top. This is a, or we could do on the bottom, F-16 style. But let's still pull it in a bit. That's better. Okay, now the canards. Pressing X can change your symmetry mode. Not the symmetry mode. Oh, yes, the symmetry mode. The angle snap is C. So I want to... Yeah, that's okay. Now our center of lift is a little bit far forward. So I am going to want to put something in the back known as a vertical stabilizer. Actually, I want two vertical stabilizers. Like that. That gets into a good position. But what happens when we lose fuel? Well, it doesn't deviate too much. That's not too bad. Might be a little bit far forward. But for now, I think it'll be alright. Well, let's test it out. That's what Sandbox is all about. Do not be afraid of making mistakes. In career mode, making mistakes might get you into trouble, but Sandbox is for making mistakes. And so, just try not to kill your Kerbals wantonly. Well, unless that's your thing, I don't know. Some people seem to enjoy that. Okay. Wheels. The thing about wheels is your main landing gear has to be behind your center of mass. No choice, otherwise your plane will tip over. Trying to find shift... Okay, shift A is the right way to go here. Okay, we have one intake and one jet. Hopefully that'll be okay. We can't go very high altitude with a jet. We do have a very nice wing, so we're not going to be short of lift. Okay, it's a pretty light craft. It's only 4.1 tons. Let's try it out. Well, yeah, let's try it out. Let's just take out to the runway and see if this sort of thing works. Now, I mentioned that aerodynamics in Kerbal Space Program isn't particularly realistic. And there are fixes for that. There are two mods in particular that you hear a lot about. The first mod is Ferrum Aerospace Research, also known as FAR by its acronym, and the second one is NEAR. They're both made by the same person, and NEAR is sort of a little bit less harsh than FAR is. FAR is pretty darn realistic, but very focused on what you call hypersonic speeds. NEAR is a little bit more interesting. NEAR is sort of halfway. It's a good approximation. It's certainly better than the stock aerodynamics. I haven't played with NEAR. I have played with FAR, and a lot of my designing stuff is in FAR. So I'm not always confident about stock aerodynamics at all. But this one got off the ground pretty spiffly, real quick. So let's take a tour with this thing. There are a few sites to see nearby, and the most notable one is the island runway, so we'll visit that. So, here we go, that's the space complex. Once you've gotten late in the game in career mode, that's what it's going to look like. is off to the side here on this island here. And we're just gonna buzz it. In particular about the aerodynamics in Kerbal Space Program, the drag is calculated a little bit weirdly. Drag is the force that is, of course, pulling you back, pushing you back, if you will, because of the density of the atmosphere. It's calculated based on your velocity squared times the surface area that's hitting the atmosphere times the density of the atmosphere, and a drag coefficient, which they test in a wind tunnel. So basically, the bigger your... Well, the problem is, that's how it's supposed to be calculated. That's not how it's calculated in Kerbal Space Program, so it's a bit complicated. In real life, that's how you would calculate it, based on the surface area that's hitting the atmosphere, the density, and all that. And velocity squared, very important. The faster you go, the more drag you have. So if you want to go fast, better get into the parts of the atmosphere that have very little drag. But I'm never entirely clear how aerodynamics is, especially drag, is calculated in default Kerbal Space Program. So it always makes me nervous. But it worked fine this time. Basically, just focus on keeping your center of lift behind your center of mass. Make sure your wheels are in the right place. Don't put your wheels too far back or you won't be able to rotate. So you need to put them close to the center mass, just behind, sort of like the lift. Actually, you should put them behind the center of lift as well. But yeah, close by. And then you'll be able to rotate properly. If you put them too far back, you're not going to be able to rotate the craft in order to lift off of the runway. If you put them too... the problem is that you're going to be worried about scraping your tail, and especially scraping the engine off your tail. So that's going to be a thing. And I totally understand that, but yeah. Be aware that you can only put it so far back before you're not going to be able to take off. So here's the island runway. I'm not going to touch down on it. Let's see how maneuverable this thing is. I don't want to pull too many G's. Poor Kerbal in there. Jebediah. You can see I have to turn my camera. You can avoid that. You can use chase plane view. And then your camera will sort of turn with it. Now these parts that we have here for planes are relatively new. They were added in the previous version, 0.25 of Kerbal Space Program. And so a lot of the time, if you see older videos of Kerbal Space Program, including on my channel, you'll see that there are different parts on offer, and we can't build stuff that looks quite like this in the older versions. So I'm just going to return to base, I think. Now takeoff is just a matter of pulling up. Landing is a little bit trickier. And you'll see me slow down here. We were going pretty close to, we were going like Mach 0.9. Pretty close to the speed of sound. Maybe a little bit slower than that. We were a little bit low, so probably we were going, what, maybe 0.8. Something like that. Anyway, first line up with the runway. The runway heading going in this direction is 27, so it's flat west. And the other direction is 9, going east. And so if we take a look at the navball, we've got 270 there, and then right now we're about 305. So we need to be 270. Trick would be to put something close by, maybe a little marker of some kind. I'll show you how to do that. But otherwise you can just figure out how to line up. Just sight it out. These little lines on the sea are somewhat helpful, because, well, you can just sort of see there's a line there coming around there, and so we know we can line up like that. But otherwise you can just use a marker and then set it as a target. We'll design something a little bit bigger than this and see if we can test it out. This wasn't too much of a struggle. Of course, you can try and fly IVA as well. That's a possibility. This isn't too bad. I like this cockpit. But I'm probably not going to do it. If I was doing this without recording and without commentating, I probably would. But the trick is doing it while I'm trying to think of something to say. And that's pain sometimes. But actually, this makes it much easier to line up with the runway. You gotta aim for a touchdown speed of less than negative 10 meters per second. Here you see the vertical velocity here, vertical speed, and right now we're more than negative 10. Negative 10 is really harsh in terms of landing speeds. If you want to be pro about it, negative 5 would be good. Touchdown speed will depend on your aircraft, but you probably don't want more than 100 meters per second. So we're coming in pretty quick, and I'm going to try and cut throttle. Lower the landing gear. Always check that your landing gear actually is down. Just cause. Sometimes the indicator up there will show that it's down when it's not, depending on whether you've re-entered the game in some particular way or stuff like that. Jeb is excited. Now in career mode, if we were doing this in career mode, he would hopefully get some experience points from this. I wish in career mode we could start off with planes. That would make a little bit more sense. But of course this is a rocket focused piece of software. This game is meant for building rockets, so I guess it's fair enough. We're coming in a little bit fast. We gotta try and sort of hover above the runway so we can lead off some of that. It's a little bit easier to fly if you have a control stick, of course. Okay, B for brakes. Okay, so Jeb Kerman is back on the runway. Our little plane is successful. No biggie. Alright, so with that, let's go back to the spaceplane hangar. We can just recover vessel here. Now in Sandbox, you're not going to get any science or any value from parts returned. All you've got is your crew ready for the next assignment, but that's important, so make sure you do recover them. Poor little Kerbals scattered across Kerbin without being recovered would be very unhappy. Alright, back to the spaceplane hangar.